Hi everyone, good evening. I've just turned off the video because, yeah. Okay, so today we would be talking about OWASP Dependency Check, which is one of the project or a vulnerability scanner from OWASP. But before that, I want to introduce myself. Um, I am Vandana and I am part of OWASP Bangalore Chapter and I'm OWASP Bangalore Chapter Leader. Apart from that, I am Women in Appsec Secretary and Asia Lead. So as Tanya says, that I have OWASP love. So I'm really interested in OWASP projects and the different chapters that OWASP has, and really like to contribute towards the work that all the people do for OWASP. Now, we would be talking about how dependency check works, who all can use it, what are languages it supports, and mainly what are the basics of it. How what's its relationship with OWASP, how it started off, and how are we going to work with it. Uh, about the history, it started off in 2011 by a team of volunteers who wanted to contribute to the society. And these are the three people: Jeremy, Steve, and Will. They have also published a paper around the dependency check and why this tool is important for us. Now, after publishing the paper in 2013, WASP actually released the OWASP 2000, the top 10 2013, which is using components with known vulnerabilities. And it made the OWASP made sure that we are making this vulnerability as part of the top 10. And why? The main reason is why, because this vulnerability is widespread. This vulnerability is everywhere. Developers everywhere are using the open source libraries and extensions, but we are not validating it. Uh, People or the developers or we are aware that we have to do the code review, but how much secure it is. The tool says, let's say we are using a tool to verify our code base or our even the IDE. Let's talk about IDE. IDE can detect whether there is a loop condition or there is some mess up that we have done in the code. But what about the third party libraries that we are using, or the third party extensions that we are using in the code? If there's something not working, we'll just download the library from the internet, or we'll pick it from the other source. So this tool actually helps in finding those flaws which are there with the third party libraries. Uh, why there are why there is a difficulty in finding the known components with vulnerabilities? Because we as a developer or the security testers, now the security testers are finding bugs in the libraries and in the code base itself, and it's a kind of a combined package that is coming up. uh, and why in the earlier ages, in the earlier years, people thought that or these volunteers thought that why this tool is important is because of the visibility. uh, as I told, that the IDs can tell you the loop condition and the flaws that we create or the mess ups that we create in the code, but that doesn't apply um, to the libraries or the third party extensions. Also, the patching process. When we patch the code, um, we just forget about third party libraries because we say these are not part of our code and these does come under our purview or our scope. So if that doesn't come under our scope, we never tend to look at them. And that's when the lack of tooling comes into picture. We did not have relevant tools to figure out uh, what all issues are cropping up in the tool because of the third party extensions. I'll be actually highlighting certain issues that are actually talked about a lot in the past. So, if I tell you about this 2015 vulnerability, code execution vulnerability, which was the talk of the town, wherein nobody was ready to take the ownership, neither Jenkins nor Apache. It created a actually havoc in the industry that a lot of applications were vulnerable to remote code execution. Literally, all the hackers could uh, do the remote code execution on our applications. Uh, but in the end, Jenkins released a patch, and then Apache also released a patch on top of it. But nobody took the ownership of it. So we as developers or security testers have to find out which are the outdated extensions or the libraries being used in the code. The same way with the 2016 toolkit, Java information disclosure vulnerabilities with XXC, nobody was ready to take ownership in that. So when the damage is done, nobody would take the ownership. So best is to maintain a library that what are the third party extensions we are using in the code. And this is the recent one, the 2018 one, Java serialization vulnerability, which caused a big denial of service attack. And we've heard about the Equifax attack or hack, wherein uh, it actually caused a huge damage to Equifax, and same way. All the organizations started to fix those vulnerabilities, started to fix the Apache vulnerability. I'll tell you, in my organization, it was a big task to even figure out um where all Apache version or outdated version was running. Even though we have an enterprise application library, but um, it's a big task for the developers to keep a track of all the libraries, all the versions that they are maintaining. Um, if to give you the figures, 95% of the application includes open source, and 67% of the application contain open source vulnerabilities because of these uh, libraries or the extensions that we use. There's a paper that has been given by Black Duck. They say that average age of open source vulnerability identifies 1894 days, which is like a big number. Now we are talking about 0 days and tend to fix the vulnerability as soon as it comes. But 1894 days is like a huge, uh, I I would say, number of days. Like, how can a vulnerability stay in the system for 4 5 years? When we talk about that, we are on top of fixing all the bugs. Thanks to WannaCry and other ransomwares, wherein they brought security into Limelight, wherein now people know that security is something, and people have started talking about other 0 days and malwares and security news. What I've seen that when the WannaCry came into picture, a lot of my family members also started talking about security. They started whether to use the phone or not, whether to use this app or not. So this tool actually helped in some way wherein you can actually leverage or test the open source libraries that you're using. Okay, so the languages that supports is um, the languages that it supports are Java and .NET, which are fully supported. Wherein you can use jar files and the files are Java based. You can just run the scan on it and can actually assume that it will give you 95% accurate result. But it does have an experimental analyzer plugin or extension plugin for other languages as well, where in Python, PHP, Node.js, Ruby. But that might not give you that accurate result because the research is still going on, and trying to figure out how best the false positives can be weed out and the best results can be taken out. In 2013, they had they were only supporting Java, and they were able to run the scans through command line interface, and there was a Ant and Maven plugin. But now, last year, they did a lot of iterations and updates, and they came up with the other plugins as well. Now we have Jenkins plugin as well, which is an important plugin wherein you can halt, or you can actually push your code base or your iteration to a state wherein it will highlight if a developer has made any changes into the code, and due to the third party libraries an issue has crop up into the production environment. It will say that it has gone to the warning status, or it'll highlight those things because of Jenkins. Or before even going to production, you can actually integrate it into your environment and see whether your code base is safe or not, with all the third party extensions. These are the file type analyzers it has. I would be sharing the links wherein you can see what all file it analyzes. These are just a sample of it, but there are many more which they keep on adding to it. How it basically works, it actually when you run it, it checks the NVD database, which is National Vulnerability Database of common vulnerability and exposure. This gets downloaded locally, so that you don't have to every time download the whole set of vulnerability database. So it always references National Vulnerability Database. There are tools which uses the other databases which has more which have more vulnerabilities, but as it's an open source tool, so it uses NVD database, and also queries also uses CVE, that is a sign that is there for a particular vulnerability, and that CVE would be assigned with the CVSS score, and it will also be mashed up with CPE, which is Common Platform Enumeration. I'll be explaining more in the later slides, and I'll also be showing you the demo wherein you'll have a more relationship that how it uses the NVD database and how the CVE is used here, and how the scoring system works, or for this particular tool, and how much how much CPE is important here. Now, this is the script generally we use, which is available online, but I'll give you a demo now so that you have a better understanding of the tool before I move on to the further slides. So this is the place wherein you can download the tool, and once the tool is downloaded, you can extract the zip file, and it generally downloads in the bin file, and it has a bat file and a SHL shell file. Now I'm going so this is where I'm going to the bin folder where my dependency checker is, and I'm going to use the script which I was showing on the screen. So I have defined the file type as an HTML. I am defining the path where my jar files are, because that's very important to define, because if you don't define the path, it would not be picking up the accurate jar files. I tested it on my own system so that I can check whether it tests the jar files on my system as well or not. And then you also define the output file and the project name that you require. Once you run the script, it takes some time to run the whole scan. The first time it takes a little bit more time because it actually downloading the whole NVD database locally. But in your subsequent scans, when you run like 2-3 times in a week or more than that, then it will only do the delta scan on the NVD database, and it will only be downloading the updates. So let's say if I have downloaded the update last week, it will, and now I'm running the scan again. It will run the scan. It will actually download the checks for from last week to this week. But when the scan is run, it will be run on the whole NVD database, so that it's not taking much of your time. And how much it is feasible for the enterprise, I'll be explaining that as well in the subsequent slides. Now, this is the scan that it has run. It has done the check on the NVD analyzer and different analyzers that it has. It also, if you see, it has the output, the result in an HTML file, which I'll show now. Once here, if you see that it's actually querying an index, which is an leucine index. It creates or it maps up with the CPE, wherein it identifies the vendor, what's the vendor, what's the product, and what's the version it uses. Because based on those things, it creates a bucket. The tool creates a bucket that yes, this is the vendor, this is the product, and this is the version. Because every version has a different vulnerability. So and every version has a different flavor. So it categorizes based on that and give you the results. Now we would be moving on to the results section, wherein um, so this script would be shared with you along with the slides so that you can use it. And I'll also be sharing the reference link so that you can modify the script as per your need. I generally take out the format, the results in HTML or PDF format, and there are other formats which team is working on it. And if you know that this can be done in a different format, feel free to contribute towards it. Now, this is how the report looks like, wherein it gives you the dependency. Dependency is nothing but the file that it checked for the vulnerability. Now, CP is basically the product, the vendor and the product and the version details. GAV is basically used for categorizing your product details. And then your high severity basically tells you whether it's a high, medium, or a low vulnerability. It checks this is being provided by the NVD database, because NVD database contains the severity, then the description of the vulnerability, and the CVSS score. Because most of the organizations prefer using CVSS score. And it also tells you that how many CVEs are present in that particular file or the dependency. It's very important to understand the CPE confidence. Higher the CPE confidence, less likely it will be a false positive. And it will also give you the evidence count, that how many evidence it is found in the particular library. Now, there is one more important thing to look at here is when you are analyzing the reports, you have to actually look at the low findings first, so that because why because it has the low confidence, and they are most likely to be suppressed first. Now, I will show you. If you see here, I'm going here in the results section, and it gave me a whole bunch of information, wherein what's the CV score, what's the CV ID, so that we can actually now mm, um, before going into this, you can actually use the results which has come out of this tool and import it to other tools as well, because it's using the industry standard. You can import it to Sonar as well, so that you can analyze it later. And there is another tool that is there, which is again an open source tool called Dependency Tracker. You can actually import the details there as well. Um, Here, it actually gives you the CVE ID, so that it'll be easy for you to figure out which vulnerability it is as per the market standard. And if you want to refer to certain more recommendations from the industry, there must be some blogs, there must be some write-ups on this particular section, which might be very interesting for you. So you can actually go back and take a look at it, and it gives you a brief information on why it has detected this vulnerability and on which version it is there, and the same vulnerability is affecting what all other versions of let's say here it says that it is affecting Red Hat, Fedora, SUSE Linux, or SUSE. It gives you the nice overview on all the associated vulnerabilities, and it also gives you the patches as well from the NVD database. You can actually go line by line and see what all can be fixed. You can sit with the developer and see whether it's actually a vulnerability or not. If you see there is a discrepancy, you can suppress that. I'll just move on to the suppression file, wherein uh, once you run the scan, automatically it creates a suppression file, wherein you can modify it. Uh, if you know that there is a high finding which is a false positive and you want to add to it, you can modify this file and you can load it, and it's pretty easy. Especially in the low cases, we generally know that they might be false positive, or we might want to exempt it, and business wants to take an exception for it, so you can just load it. I will just go to my slides and show you how you can. So here, it's a small snippet that you can use. You can define the file, or you can define the path which you actually want to suppress. Um, how it actually finds the when the results come out, the result is basically in the form of evidences. What those evidences are nothing but those evidences contain the file name, manifest or POM file in case of the Java jar, and then it also groups it into vendor, product, and version collections, as I mentioned in the as I showed you in the scan results. And also it creates a local copy of NVD database. Now these things are there, but how about using it in your enterprise? What we have done is we have created a central server, wherein we have a local copy of the database, and checks the internet and keep on downloading the updates on a daily basis. You've set the timer wherein it downloads the updates, and the same way you can actually copy it, or you can push the updates on your other systems, wherein which are actually running the scans on the code basis, and which you do not want to have internet access. So it will be only pulled from the central server, not from the internet, because we want to have those segregated from the in the server which has access to the internet. Uh, you can also use this dependency check as part of your CI/CD pipeline, which is a continuous integration and continuous deployment, and it works really well. We have tried and we have actually tested this, and we have also imported the results from this particular tool, and we have imported it to our using our Sonar plugin. We have used it into our Sonar tool. Also, you can actually import the results from this to Defect Dojo as well, so that you can track the defects. I would also like to highlight something here. When we are talking about evidences and libraries, there is always two things: false positives and false negatives. False positives, you can suppress it, but false negatives, we all are working on it. The developers, the people who are using this tool, they are sharing the information that this is the issue that I face. There's one example that is there on the screen wherein developers use a certain naming convention when they are using the library. That's in case of Maven. They have certain naming convention. But when we talk about security, there's a separate convention altogether. And this tool or any other tool can miss out on figuring out what what exactly platform it's using, or framework it is using, because of the naming convention mismatch. Even a single hash, if there is a uh, if there is a let's say you have built the code base from your source library, uh, and there's a different naming convention you've given to the framework. You've changed the naming convention suiting your source code. So then there will be issues which will actually come under false negative as well. Uh, Now, I want to also actually want to tell you that why it's very important to use in the organization, because what I have seen in the past, that when we started off using code review tool, we have a professional code review tool, but the team never thought of using any industry benchmark or an industry standard tool uh, for these third party libraries and extensions. We gave a proof of concept, and we actually gave them a business justification saying that this needs to be in place. Now, when we talk about getting a professional tool, there is a lot of money involved, a lot of approvals involved, and um, many other things play a role. So we said that, okay, now till the time we are getting the approval, we are getting the other tools in place, why don't we use this tool as a benchmark and see what results this tool is reporting. And same way, when we're doing a POC for the professional tool, or the market, or the tool which is a paid tool, uh, why don't we compare the results? And believe me, I can't take the name of those tools, but this tool gave better results. That's why I really like this tool. And I always recommend using this tool as a baselining tool, because this tool has been, we have done a proper POC at an enterprise level. And not just me, but I've seen a lot of developers coming up saying that they have used it after taking in internal approvals, because they tested on the test server, that worked really well, and then they moved it to the production, and now they're using it as part of their CI/CD pipeline. Now, any questions? Okay. It does. checks for the hashes as well. Because earlier it was only checking for file links, but then now the modifications and enhancements have been done, and the new version it tries and checks for the hashes as well. Sure, absolutely. Any questions that you have, or uh, you have any analysis done which can be helpful in modifying or enhancing the project, that'll be really helpful. I will actually show you certain references or links wherein you can actually be a contributor to the project. See here, if you see here, uh, now you're using this tool, you can actually share your feedback via the mailing list. There is a mailing list. I'll share the link wherein as soon as they make any enhancement, let's say if they've done any enhancements last week, you will see that as part of your of their mailing list. And even you can report the issues on GitHub as well. If you want any feature enhancements and you have a idea that this is how it can be done, you can be a contributor and you can share your thoughts around it. And all the links are readily available. You can refer them, you can share your inputs. Also, these are certain links which are really which I've actually gone through, and which are really helpful in giving you the basic understanding and to move forward, to use this tool, or uh, to use other tools by using this as a benchmark. Because I wouldn't say that you only use this tool, but I would say that as it's an open source and free for the community, just try and see how much it's useful for you. And when you're going to buy a professional tool, how much the results you can actually compare it, because generally we compare apple to apple. So you can compare. You can at least have a way to compare from apple to orange as well, so that you have a view that this if this is an orange, you might have an apple in hand, or you might have both. You might have apple in both the hands, and this tool is helping you in a better way as an open source. Because I know that a lot of organizations really frown when they hear about free and open source tools or FOSS tools. But now most of the organizations have started to contribute towards open source community, and they really started liking all the open source work that is there uh, in the internet on the internet. So the same way which I was talking about a dependency track also. So there's another project which is on the same lines, but it actually tracks from the start till the end, and how you can integrate with the Sonar plugin. The links are right here. There's also a YouTube tutorial on dependency checker and dependency track. Both are in combination. That's how you can use both the tools and fulfill the CI/CD pipeline, by making sure that your third-party libraries or the extensions or the binary files that you have are not causing issues in your code base. Because uh, uh, now when we talk about patching the code is patched, everything is gone to the production. We have saved the X amount of money. But if there's a third party plugin which is creating an issue for your code base, you'll have to do the whole work again. So all the security testers, developers, the project planners, everyone has to come together and see how best we can work it out on the third-party libraries. And that's when OWASP decided to have this vulnerability also as part of OWASP Top 10. It came in 2013, and it's there in 2017 as well. Even though it's a A9, but it actually plays a really big role, because there's no vulnerability which is small. We have seen in the case of Equifax and the other hacks that have happened in the past.